Well, welcome. I'm JJ. Let's work an example problem. We're trying to figure out what's the moment that F1 and F2 will cause about point A. So another moment. So let's just jump in and go for it. We're summing up our moments about point A to get that resultant moment out. So we can write that out with, we always assume a positive rotation direction, and we'll get that at the beginning. With positive going counterclockwise, we're summing up our moments. We were told to do this about point A. So we'll say about point A. Again, positive assumption in there. We're summing moments about whatever point we're asked to do. Or down the road, we'll have to choose our own and kind of strategically do that. But summing moments up about point A. We can work with F1. Let's split that into X and Y components. We would have a little X component right here and a Y component going up. We don't need to get the exact same size. We're just going to use those to figure out our rotation directions. Where for moment, we base positive or negative on our assumed rotation positive direction. So let's start out here and get our F1Y. If I'm drawing F1Y, remember we're going to draw a quick circle. We'll go along the arrow, and then whatever that naturally points us towards, try to complete a circle about point A, or whatever point we're summing moments. So here I would come up along the arrow, and then get a circle, I'd be going down and around. I'm going counterclockwise. So F1Y's moment should show up in this equation as a positive. So let's get it in there. F1Y is 12/13 of my force, 100 times 100. That's so far all that I've gotten in here. This is just F1Y. To keep going with that, I need for moment force times a perpendicular distance. So it's my shortest distance from my force back to A. I'm working with the Y component, so I'm coming from here over in the X direction to get to A. That's my 10-foot distance times 10. My Y component of force, we always will multiply by a distance in the X. Will get us our perpendicular distance. Fy dx. Now we can check our Fx. Fx points to the right here. If I were to try to circle starting this direction and going around A, I'd have to go up or below it in here. Or that one went clockwise around in our circle. That clockwise means I need to subtract this out. It's a negative moment for what we set up and assumed in here. So minus Fx dy. Notice, even though this force points in the positive x direction, its moment is coming up clockwise, which means we're subtracting it out. So minus Fx, 5/13, our x leg of the triangle divided by the hypotenuse, times the magnitude of our force, 100. Again, that was just F1x, F1x, and I'll need to multiply by a y distance. So it's my shortest possible distance from the line of action of that x component, that one that goes infinitely in front of and behind, down to A, my perpendicular distance, 3 feet. So times 3. Times 3. Or really, that's getting me, that's my dy distance. An x force times a y distance. We're not done there. I also need to check F2 in here. So let's get its y component first. It would be, if we mark it off, the y component points downwards, the x component points to the right. On that y component going down, we'd make our circle clockwise. I'm going to erase these first two just so we have a little bit more space to keep this from getting super cluttered. We're just going to set up and do moments again. So we have that y component. If I follow the arrow, I circle around A, we're going to get something that looks like that. It went clockwise, so I need to subtract this out. Minus F2y. Well, my angle here, it's measuring from vertical. And my angle symbol touches a y component here. That means that y component is adjacent. I need to use cosine for this. So minus my force is y component, 150 cosine 70. Because we're coming from vertical for our angle, cosine goes to the y component. It is adjacent to how the angle is measured. 150 cosine 70, all that I have right there is, this is f2y. So I need to multiply by an x distance. Y goes with x every time. So it's my distance from the y component, my arm, back to A, 10 feet, times 10. Or that was dx for this second forces y component's moment. And then finally, we can check our x component here. Pushing to the right, if we trace that one to circle around A, I'd have to go up and around and then come back down. Or that was counterclockwise that I just drew in there, circling around A. Counterclockwise we assume to be positive, so we'll add this in. F2x would be 150, and that sine, or the x component, would be opposite that angle, so sine 70. Again, all that piece is my F2x, force 2's x component, and I need to multiply by the distance from my arm, the x component, up to A. I'm going in the y direction to make that movement. I'm going up 8 feet. So times 8. Times 8. It's going to get me my dy term figured out. From there, really, I just need to punch this all into my calculator. I'm going to get here that my total moment, summing my moments up about point A, is going to be equal to, all of this adds up to be positive, so I don't need to adjust anything in here, but 1,423 pound-feet. Our units of force times, we put a dash in for a moment, times our units of distance, pound-feet. I assume positive was counterclockwise. I got a positive number out, so this is counterclockwise. Our final answer we always want to report as a positive and get that correct rotation in there. That would be our final answer. Moments is something that's critically important for us. Take the time to fight through this one. If moments are a struggle, everyone tends to struggle with getting the right distances in there and the rotation directions. You're not alone in that. Keep working with that. This becomes like fundamental statics. It's something that will keep showing up in all of your classes from here out. Moments don't go away ever. So get this figured out. But we can do it. We can get you there. If this was useful, hit that like and subscribe button, and let's get you in A with JJ.